What does pouring thousands of tons of concrete have to do with being a good father?
It's a wildly unexpected comparison, honestly.
Right. Welcome to today's deep dive. I'm so glad you're joining us for this one because we are unpacking a highly unusual, honestly kind of poetic document today from a company called Roots BIM LLC.
And I'm excited to be here to help break it down because on the surface, this source material, well, it just looks like a corporate celebration.
Exactly. They're marking their third Foundation Day, which happens to perfectly coincide with Father's Day.
Yeah.
But our mission for this deep dive is to explore how this text draws a direct, unbroken line between the quiet, protective role of mentorship and fatherhood.
And the intensely complex, data-driven world of modern structural engineering.
Yeah. Okay, let's unpack this. Because building a legacy, as this text argues, isn't just about steel and architecture. It is about, like, hidden intelligence.
I mean, the document is really a masterclass in synthesizing two worlds that normally never interact.
Oh, absolutely never.
You have the emotional, very human act of guiding a family or, leading a team placed right next to the uncompromising mathematics of structural engineering.
It's just such a stark contrast.
Right, and Roots BIM uses this overlap to make a profound argument. The things that actually ensure a building, or a person for that matter, will survive the pressures of the real world are almost always invisible to the naked eye.
The document opens with this fascinating contrast, stating that some foundations are made of concrete, but others are built through guidance, discipline, protection, and vision.
They are separating the physical material of a building from the intangible values that actually make the project work.
Yeah, to put a visual to this,
Yeah.
think about a kid finally stepping out into the real world, moving out of the house.
A big moment.
Huge. And a parent's goal isn't to walk behind them forever, fixing their mistakes. The goal is to have built such a strong internal framework of discipline and vision that when the inevitable intense pressures of reality hit,
That kid doesn't collapse.
exactly, they don't collapse. And the text argues that the architects, the engineers, the mentors, they're essentially playing that same parental role for these massive physical structures.
What's fascinating here is how the source moves past broad philosophy and specifically defines what that intelligence hidden beneath the surface actually looks like in the real world.
Oh, they get very specific.
They do. They list structural integrity, coordination precision, lifecycle planning, risk mitigation, sustainable performance, and long-term resilience.
Okay, let's pause and focus on lifecycle planning and risk mitigation for a second, because that phrasing feels incredibly deliberate.
How so?
Well, I mean, that is parenting in a nutshell. You aren't just putting a bandage on a scraped knee today, right? You are trying to look 20 years down the road, anticipating systemic failures, and adjusting your strategy right now so those failures never happen.
That's a great point.
But how does that actually translate to a concrete foundation?
It comes down to anticipating stress. The strongest projects are never defined by their architecture alone.
Really? Because that's what everyone takes pictures of.
Sure, but the architecture is just the aesthetic shell. It's the part we all look at. The true strength is in how the engineering team plans for the entire lifespan of the structure.
Oh, I see.
Like, how will the load-bearing columns handle a shift in the water table 50 years from now?
Right.
Or how do we mitigate the risk of an internal system failing and compromising a critical hospital wing? A mentor builds resilience into a person so they can stand on their own. An engineer builds resilience into a structure so it can survive long after the construction team has packed up and left.
Man, that's heavy. But, knowing a building needs to be resilient and actually making it resilient are two very different things.
Absolutely.
If human foundations rely on the discipline and vision of fathers and mentors to provide that hidden intelligence, what is the technological equivalent? I mean, how does a company like Roots BIM practically guarantee a hospital won't fail in 40 years?
Well, the text introduces us to their core methodology, which is BIM, or Building Information Modeling.
Okay, BIM.
Yeah, but Roots BIM is very careful to redefine what BIM actually means in practice. They emphasize that for them, it is far more than just digital modeling.
So it's not just a fancy 3D picture.
Not at all. They call it a foundation-driven ecosystem.
Okay, wait. Ecosystem sounds like one of those corporate buzzwords that gets thrown around a lot.
Yeah.
So what does this all mean?
Fair point.
I'm going to need you to break that down. When the text talks about an ecosystem where data, engineering, and collaboration work together, I'm struggling to see how that's different from just like a really detailed blueprint on an iPad.
Okay, think of a traditional blueprint as a photograph. It represents a single moment, right? A static set of instructions.
Got it.
If you change something on page 4 of a blueprint, page 40 doesn't automatically know about it until a human being manually does the math and redraws it.
Which sounds like a nightmare.
It is.
Yeah.
A BIM ecosystem, on the other hand, is parametric. It behaves much more like a living, breathing central nervous system for the building.
Oh, wow. Okay.
Every single piece of data is interconnected.
So, if an architect decides to move a structural pillar 2 feet to the left in the digital model, what happens in this ecosystem?
The system instantly recalculates the ripple effect of that decision
Automatically.
automatically. It calculates how moving that pillar affects the load-bearing capacity of the roof. It identifies that the pillar is now, say, blocking a major air conditioning duct.
Oh, I see.
It updates the total volume of concrete required, which immediately alters the project's financial budget,
Yeah.
and it flags a delay in the construction timeline.
That is insane.
The entire building reacts to the change before a single shovel of dirt is even moved in the real world.
If you were listening to this
Mhm.
and you've ever survived a nightmare home kitchen renovation, that terrible moment you realize the custom cabinets you ordered block the new plumbing for the sink and everything just grinds to a halt.
A classic problem.
Right. Now, scale that panic up to a 50-story hospital.
The stakes are just slightly higher.
Just a bit. And the document actually lists the kinds of spaces Roots BIM work on. Mission-critical facilities, commercial developments, healthcare infrastructure, residential projects, and complex MEPF coordination environments.
We should definitely unpack that acronym, MEPF, because it perfectly illustrates why this living brain is mandatory, not optional.
Okay, let's hear it.
MEPF stands for mechanical, electrical, plumbing, and fire protection.
Oh, man. Just visualizing those 4 systems fighting for space in a ceiling makes my head spin.
It's incredibly dense.
You are dealing with massive steel HVAC ducts, miles of high-voltage electrical conduit, pressurized water mains, and highly sensitive fire sprinkler systems, all in the same ceiling.
Exactly. And consider the alternative. Historically, the plumbing team had their drawings, the electrical team had theirs, and the HVAC team had theirs.
And they didn't talk to each other.
Not perfectly. They would all show up on the construction site, climb up on their ladders, and realize they were all trying to install their equipment into the exact same 3-foot gap in the ceiling. Yeah, the physical realities simply clashed. Fixing that on-site means massive delays, tearing down completed work, huge cost overruns, and sometimes even compromising the safety of the final design.
But the BIM ecosystem stops that.
Right. It prevents that by simulating the physics and geometry of the entire structure down to the millimeter.
That brings us to the specific, highly advanced toolkit the text outlines. Roots BIM provides this really dense, technical bulleted list of workflows they've used over their 3-year history.
They do. It's quite a list.
They mention things like 4D construction sequencing and logistics simulation, 5D cost-integrated BIM workflows, and advanced clash detection and coordination.
It can sound like a lot of jargon.
It really can. I want to try an analogy here to see if I'm grasping this. Is this essentially like planning a massive, highly complicated family road trip?
Okay, let's see where you take this.
Okay, so the 4D construction sequencing, that's the dimension of time.
Right. Yes.
So that's the incredibly detailed road trip itinerary. It's knowing we leave at 6:00 a.m., hit traffic at 8:00 a.m., and arrive at the hotel exactly at 4:00 p.m. so we don't show up before check-in.
That tracks.
In construction, it's knowing exactly when the steel beams need to arrive on site, so the really expensive rental cranes aren't just sitting idle for 3 days.
The logic totally holds. Adding the 4th dimension, time, to a 3D model means the building virtually constructs itself on a timeline, which reveals logistical bottlenecks before they happen.
Awesome.
And the 5D cost-integrated workflow.
Okay, that's the budget for the road trip, but inextricably linked to the itinerary.
Right.
If we decide to stay an extra day at the Grand Canyon, the 5D model instantly tells us exactly how much that will cost and extra hotel fees, gas, and food.
Precisely.
In a building, if the steel delivery is delayed by a week, the 5D ecosystem automatically calculates the financial bleed of extended labor contracts and equipment rentals. The money is tied to the time, which is tied to the physical geometry.
That covers 4D and 5D really well. But how are you conceptualizing advanced clash detection?
Oh, that's the parent realizing that 2 kids who constantly bicker cannot be assigned the same seat in the minivan and reassigning them before the trip even starts, rather than dealing with a meltdown on the highway.
Okay, the minivan analogy is fun.
I thought so.
But in reality, clash detection is far more rigorous than just separating two entities. Think of it more like a temporal immune system for the project.
A temporal immune system. I like
It
that.
doesn't just stop an argument.
Uh-huh.
The algorithm scans millions of intersecting data points across all those MEPF systems we talked about.
Right, the plumbing and electrical.
Yes. It calculates the spatial geometry in 3 dimensions and literally prevents the structural equivalent of a disease from ever taking root.
Wow.
It raises a red flag in the software saying, hey, you are routing a high-voltage electrical line straight through a pressurized water main.
Which would be catastrophic.
Exactly. It forces the engineers to cure the disease in the digital space, where it costs nothing, rather than cutting into real steel on the job site.
Okay, that makes total sense. A digital immune system.
Yeah.
But the document keeps throwing more acronyms at us.
There are a few more, yeah.
They list LOD 500 asset information modeling, Scan-to-BIM and reality capture, and digital twin integration. I'm going to admit complete confusion on LOD 500.
It's a niche term.
Are we talking about video game graphics settings here? Like, what does that actually mean?
LOD stands for level of development. It is a scale used in the AEC industry to define how much reliable information is packed into a digital model.
Okay, so a scale of what, 1 to 100?
It typically ranges from 100 to 500. LOD 100 is essentially a conceptual block, like a placeholder. It tells you an air conditioning unit will go roughly here.
So it's just a generic gray box in the software.
Yes, exactly. But by the time you reach LOD 500, that gray box has evolved into a hyper-precise, exact geometric representation of the actual physical machine installed in the building.
Oh, so it looks exactly like the real thing.
It's not just a picture of an AC unit. Embedded inside that digital object is the manufacturer's name, the serial number, the exact installation date, the warranty expiration, and the specific maintenance schedule for the fan belts.
Wait, really?
No.
Why go to that level of insane detail? I mean, who is looking at the serial number of a virtual fan belt?
The facility manager who inherits the building 30 years from now.
Oh.
Yeah. Roots BIM is creating an instruction manual that survives generations. When an alarm goes off in the real building decades later, the manager doesn't have to tear through paper archives or guess what part is broken.
They just click on it.
They click on the LOD 500 model, and the hidden intelligence of the building tells them exactly what to replace.
That is wild. Which brings up Scan-to-BIM. If you were building a brand new high-rise, I completely understand how you create that data from scratch.
Right?
But what if you are renovating a 100-year-old hospital? There are no digital blueprints for that. How does Roots BIM apply this ecosystem to a physical structure that already exists?
They do it through reality capture. They bring highly advanced laser scanners into the physical space.
It's like laser scanning the whole room.
Yes. These scanners fire millions of laser pulses every second, bouncing off the walls, the exposed pipes, the floors. This creates what's called a point cloud.
A point cloud.
It's a massive swarm of data points that perfectly maps the physical room down to the millimeter.
It sounds like they're creating a digital ghost of the physical room.
Exactly. And then the engineering team takes that point cloud and translates it into a geometric mesh. The software interprets those millions of dots and says, okay, this cluster of points is a load-bearing brick wall. This cluster is a copper pipe.
So they are building it backwards.
Yes, they essentially reverse engineer the physical reality into a fully functional BIM model.
And I guess this all feeds into what the text calls digital twin integration. The building essentially has a virtual copy of itself running parallel in the software.
That's the digital twin, yes.
And the document notes that all these tools, the 4D, the 5D, clash detection, the reality capture, they all operate to anticipate conflicts before they happen and protect systems before failures occur.
And that phrasing is the linchpin of the entire document. Anticipating conflicts and protecting systems before failures occur.
Yeah.
That is the definition of mentorship. That is the definition of being a father.
Oh, wow. It all comes back around.
It does. You use every tool at your disposal to see the road ahead, identify the hidden dangers, and steer your family or your team safely around them.
Right.
Roots BIM is taking incredibly sophisticated, point cloud algorithms, level 500 data modeling, and revealing them to be modern tools used to fulfill a very ancient, very human drive.
The drive to protect, to ensure stability, to lay a foundation that others can safely stand on without ever knowing how hard you worked to build it.
Exactly.
Here's where it gets really interesting, though. The text elevates this even further. It states, and I quote, Because tree engineering is not only about constructing buildings, it is about creating trust, continuity, safety, and legacy.
That's a powerful statement.
They are completely reframing the AEC industry. It is no longer just a technical job of erecting shelters to keep the rain off our heads. It is a moral and societal task.
If we connect this to the bigger picture, changing the lens from technical to moral completely alters how you view infrastructure.
How so?
Well, the desire to endure across generations is what actually drives the adoption of this technology.
Yeah,
You don't build an LOD 500 digital twin just because the software is neat.
right. It's a ton of work.
You build it so that when a new team takes over the hospital half a century from now, they have the encoded knowledge of the original creators. It is the ultimate act of passing down wisdom.
That is a beautiful way to look at it.
Roots BIM frames technology not as a cold mechanical replacement for human values, but as the most powerful extension of them we've ever created.
Let's look at the poetic symmetry of the document's closing mantras, because they really hammer this moral task home. They end with a trio of statements that tie the entire celebration together.
Those statements are a great summary.
First, strong foundations create strong futures.
That's a physical principle and a psychological one. A skyscraper with a compromised base will eventually fracture under its own weight, no matter how beautiful the glass facade is.
Yeah, that makes sense.
And a child stepping into adulthood without a foundation of discipline and vision faces the exact same structural risk. If the base is solid, the potential built on top of it is virtually limitless,
Absolutely. The second statement is, strong guidance creates strong teams.
which is a direct acknowledgement of the human element behind the software. The hidden intelligence of Roots BIM isn't just their computing power.
Right, it's the people.
It is the senior engineers, the coordinators, and the fathers they are celebrating. It is the invisible leadership that anticipates internal conflicts within the staff, mitigating risks in human collaboration, the same way clash detection mitigates risks in the ceiling.
Man, the parallels are just everywhere. And the final statement, intelligent BIM creates resilient infrastructure.
The ultimate synthesis. Intelligent application of data, the anticipation, the lifecycle planning, the digital immune system creates physical environments that can withstand the test of time.
Right.
Good parenting creates resilient adults. Intelligent engineering creates resilient spaces for those adults to thrive in.
It is just a profound way for a company to celebrate a milestone. I mean, they're expressing gratitude to their clients, their BIM specialists, their architects, but they are filtering all that professional success through the deeply personal values instilled by their own fathers and mentors.
It shows that no matter how advanced our laser scanners or parametric models get, the why behind the work remains intensely human.
Because the technology is merely the how.
Exactly. We map point clouds and sequence 4D logistics because we want to build things that matter for the people who matter to us, and we want to ensure those structures offer protection long after our direct involvement ends.
As we wrap up today's deep dive, we really want to leave you, the listener, with a challenge. The next time you find yourself walking through the lobby of a major hospital, a towering commercial high-rise, or a complex residential project, try to force your perspective past the aesthetic surface.
Look past the architecture.
Exactly. Look up at the ceiling. Acknowledge what is hidden just behind those acoustic tiles. Try to visualize that invisible digital ecosystem, that living brain of data that had to be perfectly coordinated in 3 dimensions before the foundation was ever poured.
It's all up there, working silently.
Recognize the quiet protective guidance, so much like a parent's, that was embedded into the design by teams of engineers. Their entire goal was to keep that structure standing tall, keeping you safe without you ever having to notice or ask.
Thinking about that hidden intelligence raises a lingering question, honestly, inspired by the document's focus on life cycle planning and digital twins.
Let's hear it.
We are now creating data ecosystems that allow a physical building to essentially remember its own foundation. A digital twin remembers the exact serial number of a hidden wire.
Right.
It understands its invisible mechanical systems. It anticipates its own future maintenance needs decades in advance.
Yeah.
How might this fundamentally change human legacy? Modern buildings will very likely outlast the people who engineered them. Will these massive, perfectly preserved virtual memories serve as a permanent, immortal record of the fathers, mentors, and engineers whose care and guidance were permanently encoded into the data?
Wow. Is the data we leave behind the ultimate foundation? A digital ghost that outlasts the creator? We'll leave you to chew on that one. Thanks for joining us, and we will catch you next time as we continue to explore the hidden depths of the ideas shaping our world.